The data represents the daily rainfall in inches for 1 month. Construct a frequency distribution beginning with a lower class limit of 0.0 and use a class width of 0.2. Does the frequency distribution appear to be a roughly normal distribution? So let's look at the set of data. We have data values that are mostly less than 1, but we have one here that is 1.39. And what we expect to do then is enter these frequency values according to the class limits that are given here. And we see that the class limits that we are to use go from 0 to 0.19 and then 0.2 to 0.39 and 0.4 to 0.59 and on up until we get to 1.2 to 1.39. So we have a class width of 0.2, as we can see that if we go from the lower class limit of the first class to the lower class limit of the second class, that's a distance of 0.2 and then another 0.2 and another 0.2 and on. We're going to use StatCrunch to do this, but we're going to have to be a little bit careful when we get to the step of actually creating the class limits. We're going to have to specify which class limit we want it to use when it decides which class a data value will go into, and we'll talk about that a little bit more in just a second, but just be sure and be paying attention when that comes up. So we will click Open in StatCrunch. Once the data is loaded into StatCrunch, we're going to go through a two-step process. The first step will be to have StatCrunch decide which of the classes that each one of these data values should go into. The second step will be to have StatCrunch create a table using those classes. So now the first thing we'll do is click Data, and then we're going to select Bin. Now bin is basically the same as class. So we're going to select the column variable 1. And what's going to happen is, using this process, StatCrunch is going to decide which class each of those data values goes into, and then put that specification right next to each data value in the second column. So we'll see what that looks like. We're going to use fixed with bins, or in other words, fixed classes, because the problem told us exactly where we were to start, which was at 0, and how wide the classes should be, which is the same as the bin width. So the bin width should be 0.2, just as it says in the problem. Now here comes an important point. Bin edges. We want to make sure that we say include left endpoint. And we'll see the reason for that in just a little bit. So hit compute. Now, what has happened then is StatCrunch has constructed classes, or in other words, bins, according to how we specified. They start at 0 and their width is 0.2. And so for each of these data values, they've been placed into those bins. Now what we're going to do is have StatCrunch construct a table. So we'll click Stat, Tables, Frequency. So this will be a frequency table that will tell us how many times each of the bins show up, or each of the classes show up in this list. So we'll click Frequency, and then we'll click Bin. Then we'll click Compute. Now, well, we have a table now that is a grouped frequency distribution, but it does violate one of the criteria that we specified for a valid grouped frequency distribution, and that is that they overlap. You'll notice that if we had a data value of 0.2, it could go into the first group or the second group. But because earlier on we told StatCrunch to use the left edge, then for a value of 0.2, StatCrunch will place that data value into the class that has 0.2 as a left edge. Same thing with 0.4 or 0.6. So now we'll go back to our problem and we'll look at it and say, okay, how many data values are there in the data set between 0.0 and 0.19? And according to our table that StatCrunch has produced, there are 23. From 0.2 to 0.39, that would be 3. Now we're going to be careful here because let's count the number of classes that we have in the problem here. We have 1, 2, 3, 4, 5, 6, 7, but notice there are only 1, 2, 3, 4, 5 classes here in the table. Notice that we skip the class that would go from 0.8 to 1 and from 1 to 1.2 in the StatCrunch output because there were no data values there, so StatCrunch did not bother putting a class that has a frequency of 0. So that means then that this class from 0.8 to 0.99 would have a frequency of 0, and this class from 1.0 to 1.19 would have a frequency of 0. But back here, these are in order. 0.4 to 0.6 would be 2, 0.6 to 0.79 would be 1, and then the last one, 1.2 to 1.39, would be 1.